Alright, so this video is to explain the origins of the quadratic formula. So we're going to start with the standard form for a quadratic formula, which is ax squared plus bx plus c equals 0. That's the standard form for a quadratic equation. Now what we're going to do on this equation is complete the square. Even though there's no numbers in this, we're still going to complete the square. So the first thing we need to do is move c to the other side. Alright, then the next thing we need to do is divide everything by a. Remember, a needs to be 1. We basically can't have the a there, so we're going to divide everything by 1, or a, and get x squared plus b over ax equals negative c over a. Now the next step in completing the square is to take b, which is actually b over a here, we need to cut it in half, which is b over 2a, then square it, which is b squared over 4a squared, and add that to both sides. So x squared plus b over ax plus b squared over 4a squared. We're adding it to both sides. Alright, now the next step is on the left side, we're going to factor that. We're going to write this as a binomial squared. And we've said all along that if you don't know what goes here inside the parentheses, it's always this middle step here. So it's going to be x plus b over 2a. If you were to actually multiply this binomial by itself, you would get this right here. Now here on the right, what we're going to do is we're going to add these fractions. These are fractions with unlike denominators, so we need to make them have common denominators. So the common denominator here is going to be 4a squared. So I don't need to multiply the second fraction by anything, so I'm just going to leave it as what it was. But the first fraction, we need to multiply the numerator and the denominator both by 4a. Right, there already was an a there, but we need to have two a's. We need to have a times a. So we're going to multiply the top by 4a. So that's going to be negative 4ac now. Alright, now the next step is, completing the square, is to square root. So we're going to square root both sides here. When we square root everything on the left, the squared goes away and we're just left with x plus b over 2a. On the right, we are going to first start by combining these fractions and getting negative 4ac plus b squared all over 4a squared. Since they had common denominators, we can add. Now what we're going to do is, when you square root a fraction, you can square root the numerator and the denominator separately. And the reason why I'd want to do that is the denominator is actually a perfect square. That's square rootable. So we're going to write it like this. And the reason why I did that is the denominator can be square rooted. And it's going to be negative 4ac plus b squared all over 2a. Now when we square root, we have to remember that somewhere here we need to make a plus or a minus. Remember, there's always two answers in a square root. Okay, so we're just going to put a plus or a minus sign out here. Okay, when you square root, remember there's always two answers, a positive version and a negative version. So if we just put that plus or minus sign out there, that'll take care of both of those possibilities. So now the last thing we're going to do here, almost last thing, we're we're going to solve this equation in terms of x. So we're going to make it so x here is by itself. That'll be easy. All we have to do is move this b over to a to the other side. So we're going to do plus or minus square root 4 negative 4ac plus b squared all over 2a minus b over 2a. When we move that over, you notice it's a fraction that already has a common denominator with the fraction that was there. So we're going to combine these two fractions. So we're going to get plus or minus negative 4ac plus b squared all over 2a minus b. So believe it or not, this is the formula we've been trying to get here. The only difference is when they do this formula in math, they have the order of this arranged a little differently. So the official formula for this is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We had everything here in this formula, it was just in a different order. The negative b was at the end and we just moved it out front. The plus or minus was in the front, we moved it in the middle. And the b squared minus 4ac was already under the square root, just in a different order. So what's the big deal about this formula? This formula is called the quadratic formula. And what it does, it's very powerful. What it does is I can take any quadratic equation in the standard form that we've been seeing, you know, the ax squared plus bx plus c equals 0. I can take any quadratic equation in that form. I can just take the a and the b and the c from the formula, you know, basically the coefficients and in c's case the constant, and I can put it in that formula here in red. And if I evaluate that formula, it's going to tell me the roots of that equation. I don't have to factor, I don't have to complete the square, I don't have to graph it. This formula will tell you the roots of any quadratic formula, any quadratic equation, without you doing anything other than plugging in numbers. So that's very powerful. It's also powerful because a lot of times quadratic equations have roots that are not integer roots. They're irrational decimals. They're roots that are very difficult to find. You cannot find them with factoring. If you were to graph them on your calculator, you'd see that they were decimals that are non-repeating. And completing the square, you'd end up with you know, a square root of something that's not a perfect square. So this formula works for any quadratic equation, even the ones that don't have nice simple roots. Alright, so that right there is a video on deriving the quadratic formula using completing the square. Thank you for watching.